Welcome everybody to another episode of Wes Explains Best. Today we're doing a Kuta software worksheet tutorial. This is proving lines parallel, very similar to parallel lines cut by a transversal, just a little bit extra involved. This particular one has been modified. It says to also indicate by which theorem or postulate the two lines are parallel. So let me go ahead and explain. If you are a little confused or lost, I would recommend watching the parallel lines cut by a transversal video first before seeing this one. Let's go ahead and jump right into this then. Number one, we have this missing angle and we have 130 degrees and we want these to be parallel. In order for them to be parallel, these two angles need to be congruent. So this must be 130 degrees. How do I know this? Well, if we look at this as in terms of two intersections, both these angles are in the southwest portion of the intersection. Okay, so this is split up into four parts. We have the northeast, southeast, southwest, and northwest. So these are both in the southwest. They're both in the bottom left portion of the intersection, so they need to be equal because they need to be corresponding angles. So what is the theorem or postulate? To prove them parallel, don't say corresponding. It's going to be the converse of corresponding angles theorem. Now, why is it converse? This is the part that confuses certain students. If we knew the lines were parallel first, okay, so we're given that two lines are parallel, and then we have a transversal cutting through. Let me go the other way just to make it different. And we knew that these are the two angles in question, and we don't know what their measure is. The corresponding angles theorem, just that right here, corresponding angles theorem, tells us that these two angles are congruent because the two lines are parallel. What we're doing here is the exact opposite. We don't know these lines are parallel, okay? But we want to make them parallel, okay? So if we know that these two angles are congruent, then we know that they are parallel because of the converse of corresponding angles theorem. Essentially what we're doing is we're going backwards, okay? We have to go backwards and forward in mathematics to prove things, and you have to know these theorems in order to understand this. Okay, so let's move on to number two. Number two is same thing. We're trying to prove the lines parallel. We don't know, so we want to know what this should equal. This should equal 128 degrees. Why? Because these are both interior angles in the interior space, okay? This is the interior. Here is the exterior. And we know that they are alternate interior, meaning they're on opposite sides of the transversal. Here's the transversal cutting through the two lines. They're on opposite sides. So these are alternate interior angles. But we're not writing that because we're trying to prove the lines parallel. Anytime we're trying to prove lines parallel, we use the converse of alternate interior angles theorem. So there's our answer for that one, 128 and converse of alternate interior angles. Let's move on to number four, a little bit different scenario here, okay? So again, we have interior space, but this time they're on the same side, okay? So what is this going to be? Don't just say it's going to be equal. That would be wrong, okay? This one is going to be equal to 100 degrees. Why? Because these two angles, did I use this pink? This pink I used. These two angles need to be equal to 180 degrees because they are same side interior angles. This time they're on the same side of the transversal. They're both on the left side of this guy. Interior angles theorem. Okay? Now, because we're trying to prove the lines parallel, though, we didn't know this first, then we're not going to use same side interior. We're going to use the converse of same side interior angles, and this one's actually not theorem. My apologies. It's not theorem. It's postulate. Postulates need theorems in order to prove them true, so this is a postulate because this particular but this particular case uses theorems to prove it. But that's kind of nuanced. Don't worry too much about that. Okay, let's go into a harder one. Let's go to, I'm trying to think which one's harder. Probably 10. So 10 looks a little bit more difficult. Okay, again, we're only concerned about U and V. We don't care about this guy. Okay, and we're looking at these two angles in question. Way too big. Those two angles in question. Because those two angles are the ones in question, we only want the transversal that they're both touching. So it's this transversal that concerns us. This one doesn't matter at all. So we don't care about that line. We don't care about this line. So we're really only concerned about the ones highlighted, which I'm about to do. Let's do it in pink. We're only concerned about this, this, and this, okay? All right, now the two angles in question, okay, if we kind of just get rid of all the other baloney and simplify it so that we only see the two lines we want, it kind of looks something like this, okay? Where U and V are those two parallel lines. Well, we don't know if they're parallel, we're trying to prove them parallel, but what do we have to know about the purple angles? We have to know the purple angles add up to 180 degrees. So plus the question mark equals 180. I'm going to subtract 117, subtract 117. And what is that? That's 70, 60, 63? 63 degrees equals the question mark. Okay. Now, what is the theorem? Again, because we're proving lines parallel, it's going to be converse. What is it converse of? These are same side interior angles, and this is the postulate. So just like the one we just did. Okay, these ones are a little bit different. Okay, let's go down to a tough one, number 15. 15, these are the two angles we want. The two parallel lines we want are, or to see if they're parallel, to prove them parallel, are those. Okay, these definitely look like, if this is our transversal in green, these are definitely, I don't like that. I like this better. These are definitely corresponding angles, so we know we're going to be using the converse of corresponding angles theorem. Okay, and what do we know about corresponding angles? We know that they're equal. Okay, how do I know it's corresponding? Because they're in the same part of the intersection. If I look at these two intersections here, they're both in the upper right, so that's why they're corresponding, and we need them to be equal, so we set them equal to each other. Okay, if they were same side interior, we would add them together and set them equal to 180 and then solve for x, just in case you're wondering about that. So we get 11x equals 132. So then my next step is I divide both sides by 11. And I get x equals 12. Okay, and that's all we care about, the value of x. So again, we already did the theorem, so we're good there. We found x, we're good there. Okay, and both, I think most of these are going to be very similar to that. You're going to set most of these equal to each other. The only one we didn't cover was alternate exterior. This would be alternate exterior because those are exterior angles. The interior is on the inside, and they're alternate because they're on they're not on the same side of the transversal. So what we do is we would set these two equal to each other. Plus 112. We subtract 112. Yes, x can be negative. Angles can't be negative, but x can. And we get -7. Okay, equals x. Now, what is the reason why is converse, okay, because we're proving the lines parallel. Converse, I'll use it in red. Converse of alternate exterior angles theorem. Okay, that's all I have time for today. Hope you guys found this helpful and this helps your cause in mathematics. Until next time, be good, be kind, be true, be nice, and be honest.